Welcome to a second video on integration involving partial fraction decomposition. I thought we should take a look at another example where we have a quadratic factor. So let's go ahead and take a look at our integral. To save a little bit of time, notice it's already in factored form, but we have a linear factor and a quadratic factor. So for the linear factor, we'll have a over x minus 1. And then for the quadratic factor, we'll have bx plus c in the numerator. Now we'll go ahead and multiply everything by the LCD, which would be these two factors. So on the left, both of these factors simplify out, so we're left with 5 equals, here the x minus 1 simplifies out. We have a times x squared plus 9. Here the x squared plus 9 simplifies out, so we have bx plus c times x minus 1. So because of this quadratic factor, we are going to have to multiply this out. But before we do that, let's go ahead and use the 0 of this linear factor to determine the value of a. So if we let x equal 1, we'll have 5 equals, this would be 1 squared plus 9, that'd be 10a. And this would be 0, so we'd have a equals 1/2. Now to find the values of b and c, we will have to multiply this out and then combine the like terms based upon the power of x. So we'll have 5 equals ax squared plus 9a plus bx squared minus bx plus cx and then minus c. Let's identify the like terms based upon the powers of x. So here we have an x squared term and an x squared term. Here we have an x term and an x term, and these would be the constants. So we have 5 equals quantity a plus b times x squared plus negative b plus cx and then plus 9a minus c. Now if we take a look at the left side of the equation, we could write in here a 0x squared plus 0x plus 5 if we needed to. That just emphasizes that a plus b must equal 0. Negative b plus c must equal 0. And 9a minus c must equal 5. Remember, we already know that a is equal to 1/2. So if we take a look at this first equation, if a is equal to 1/2 and a plus b is equal to 0, we know that b is equal to negative 1/2. And then looking at the second equation, if negative b plus c equals 0, well, negative b would be positive 1/2, therefore c must equal negative 1/2. So way back up here in blue, we can rewrite this integral now as the sum of these two fractions based upon the values of a, b, and c. Let's go ahead and do that on the next screen. So using these partial fractions, now that we know the values of a, b, and c, we can rewrite this integral as the sum of these two fractions. So since a is equal to 1/2, we would have 1/2 times the integral of 1 over x minus 1 dx. Now since both b and c are equal to negative 1/2, I'm going to factor out a negative 1/2. I write minus 1/2 times the integral of x plus 1 over x squared plus 9 dx. Again, if I distribute the 1/2, I'd have negative 1/2 x minus 1/2, which match with the values of b and c. Now this is going to be a lot easier to integrate in this form, but this one is still going to be a little bit of a challenge. Let's go ahead and rewrite this as two different integrals. One will be x over x squared plus 9, and the other will be 1 over x squared plus 9. So I'll have minus 1/2 times the integral of x over x squared plus 9, and then minus 1/2 times the integral of 1 over x squared plus 9 dx. For this one, if we let u equal the denominator, then du will equal dx, So this will be the antiderivative of 1 over u. For the second one, if we let u equal the denominator x squared plus 9, differential u is going to equal 2x dx. So if we divide both sides by 2, we can replace x dx with 1/2 du. So we can use a basic integration formula for this as well. And then for this last one, this should remind us of the integral of 1 over a squared plus u squared. So using this basic integration formula here, a is going to equal 3, and u will be equal to x. So I think we have everything. Let's go ahead and try it. Again, if this is equal to u, we'll have 1 over u du. So this is going to equal 1/2 times the natural log of the absolute value of x minus 1. Now here we're going to have minus 1/2, and then when we perform the u substitution, we're going to have another factor of 1/2 because x dx is equal to 1/2 du. So we'll have 1/2 natural log absolute value of x squared plus 9. And for this last integral, we'll have minus 1/2 times, again, we're using the integration formula here. So we'll have 1 over a, which is 1/3 arctangent of u over a. Well, u is x and a is 3. So we have x over 3 and then plus c. Let's go ahead and clean this up one more time. 1/2 natural log absolute value of x minus 1 minus 1/4 natural log of absolute value of x squared plus 9. This would be minus 1/6 arctangent x over 3 and then plus c. So even though partial fractions did allow us to integrate this, it still was fairly involved, but it did allow us to find the antiderivative. I hope you found this example helpful. Have a good day.